All right, today we're talking about a concept called differentiability. And pretty much just the basic concept is something is differentiable if you can find its derivative. All right, let's say I have f of x, and I want to determine if my function is differentiable at the x value of 3. Okay? If I can find f prime of 3, and that produces some number, that means that my function is differentiable at 3. So the very basic definition of differentiability is, if I can find the derivative, and then I can find a y value for that derivative, that means I'm differentiable at that x value. If I can't find a value, a function value for the derivative at a point, that means I'm not differentiable at that point. And that's the very basic definition of differentiability. Can I find the derivative? Yes, I'm differentiable. No, I'm not differentiable. Okay, that's the very basic definition. So that's what I want to start with. Now, there is a prerequisite for whether or not something can be differentiable or not. And that prerequisite is the function must be continuous. So this will be a good opportunity for us to review, to talk about continuity real quick. Because again, if I'm not continuous, I can't be differentiable. I must be continuous to be differentiable. Okay? So, Amelia, what 3 things have to happen for me to be continuous at a point?
The function value has to exist, the limit has to exist, and the function value has to equal the
Excellent. Very nice. Okay, so remember that the function value must exist, the limit must exist, and the function value must equal the limit for something to be continuous. Okay, very nice, Amelia. All right, so that's the first thing. In order for something to be differentiable, I first have to be continuous. Okay. Second part is, for something to be differentiable, the limit as we approach some x value from the right of the derivative must equal the limit as we approach some x value from the left of the derivative. And notice, what am I taking the limit of?
That or x value from the left.
I'm taking the derivative. I'm taking the limit of the derivative. That's what I've got to keep in mind and not get confused. Okay, so I first have to be continuous, and the second thing that has to happen is the limit from the right of the derivative has to equal the limit from the left of the derivative. Those are the 2 things that have to happen for me to be differentiable at a point. I must be continuous at that point, and then the limit from the left and the limit from the right of the derivative must exist. If those 2 things happen, that means I'm differentiable.
Wouldn't that already happen if it's continuous?
No.
No.
Because if we're talking about continuous, what function are we talking about when we're talking about continuous? We're talking about the regular function. But what am I taking the derivative or the limit of here?
The derivative.
The derivative.
You gave yourself away.
Okay? Yes, I gave myself away. Okay, but that's a good thought. So my function can be continuous, but my derivatives from the left and from the right may not equal each other. Okay, when those derivatives don't equal each other at a point, then that means I'm not differentiable. Okay? All right, now let's talk about a couple things that differentiability implies. It implies 2 things. Your book says it'll only imply 1, but it implies 2 things. What 2 things do you think differentiability implies? If something's differentiable, what else do you know?
It's continuous.
There you go. That's the first thing it implies. Okay, if I know a function is differentiable, I know that function is also continuous. Because I have to be continuous to be differentiable. Okay? But the opposite of that doesn't work. If I'm continuous, do I have to be differentiable? No. It only works one way. If I'm differentiable, that means I'm continuous. So that's the first thing it implies, is that my function is continuous. The second thing it implies is my derivative is continuous. So if they're telling me that some function is differentiable, I should automatically know that function is continuous, but I should also know that its derivative is also continuous. So differentiability implies those two things. My function is continuous, but my derivative is also continuous. Okay? All right, so that's the basis for differentiability, and that's everything we've done so far is what we're going to build up on the rest of the time today. Okay, we're going to use it to talk about differentiability. And we're going to start by looking at a graph. So on page 102, we're going to look at 83, 85, and 87. All right. Okay, we want to talk about the differentiability of this function. On 83, I've got the function 2 over x minus 3, and it wants me to figure out where is this thing differentiable at. Usually we figure out where it is differentiable by saying where it's not. So where is this not differentiable at? Okay, and why am I not differentiable at x equals 3? That's the answer I want to hear. Okay, the answer I want to hear is I'm not differentiable because my function is not continuous at 3. That's what I want to hear. I don't want to hear there's an asymptote. I want to hear my function's not continuous. And since my function's not continuous, that means I cannot be differentiable. So on this problem right here, I would say I'm differentiable everywhere at all real values except x equals 3. Okay? Next one. I have f of x equals x plus 4 to the 2/3, and I have the graph of it. What do you guys think about the differentiability of this one?
Differentiable from -7 to
Now, don't just say -7 because your book means for this to go on to the left and for that to go on to the right.
-7. I don't think
Okay, so I've got it's differentiable everywhere, and I've got it's differentiable everywhere from -4. Everything everywhere but -4. Okay, but remember, what two things have to happen for something to be differentiable? Number one, non-continuous. Am I continuous?
Yes.
Yes. What's the second thing that has to happen? Limit of the derivative has to exist at points. So what do I need to do to check that part? Find the derivative. So let's find the derivative of this thing. So to find the derivative, that's going to require what? The chain rule. So that is 2/3 x plus 4 to the -1/3. The derivative of the inside would just be 1. So that means my derivative is equal to 2 over 3 times the cube root of x plus 4.
Would it be negative?
No. So there's my derivative. I can't have 0 at the bottom. Now remember, we said differentiability implies two things. The function is continuous and the derivative is continuous. So if my derivative is not continuous somewhere, then that's going to cause me a problem when I'm talking about differentiability. Does anything cause me a problem and make my derivative not continuous?
Yes.
Where? 4. -4 causes a problem on continuity of my derivative, correct?
Yes.
So that one, that's the point I need to check on my derivative from the left and my derivative, or my limit from the left and limit from the right. Okay? So we want the limit as x approaches -4 from the left of my derivative, and limit as x approaches -4 from the right of my derivative. Now, Jared, what's the number one rule to find the limit? Jared. Ellie, what's the number one rule to find the limit? Plug in. So the first thing I need to do is I need to plug in -4. What happens when I plug in -4?
You get 0 at the bottom.
I get 0 at the bottom, but I also need to know what do I get at the top.
A number over 0.
A number over 0. And what does that tell me, Gentry, if I've got a number over 0? What am I dealing with?
A whole.
I'm dealing with an asymptote. Okay, and if I'm dealing with an asymptote, what's my graph going to do as I approach the asymptote?
Usually go up.
Go to infinity or negative.
All right, so that means these two limits, limit from the left and limit from the right, my only two answers are going to be what?
Infinity or negative.
Infinity or negative infinity. So I need to check that. So if I'm doing -4 from the left, I need to think about a number on the left of -4. I don't need to get an actual number, I just need to think. And I'm determining whether or not this is going to be positive or negative. So to the left of -4, does that make this whole thing positive or negative? Makes it negative.
To the left, yeah.
To the left. Makes it negative. A number to the right of -4, what does that make this? It makes it positive. So what's going on with my limits? They're not the same. Therefore, it is not
Differentiable.
differentiable.
Different.
Okay? And what is my reason for it not being differentiable?
Not continuous
It doesn't have the same.
At the derivative.
The limit is the derivative.
The limits don't
The
equal.
limit of the derivative at x equals -4 does not exist. That would be my answer there. Okay? There are only two reasons I can say something is not differentiable. What are those two reasons?
Not continuous.
Not continuous.
And the limits don't equal each other.
The limit of the derivative does not
Equal.
exist. Those are the two things that I can say for something not being differentiable. Okay, so let's go back and look at our graph and kind of think about what's going on with my graph that might tell me I should have known that it was not differentiable, and I won't have to do all that next time. What type of point?
No.
It is a minimum,
Oh, yeah.
but now you talked about this word.
An
That this,
exact.
there was a word you guys did on one of your explorations that you
What does it start with?
see.
Cusp.
A cusp.
See?
That's what I have here is a cusp, but something else we want to talk about is called a sharp turn. Whenever I have a sharp turn, I'm not going to be derivative. Anytime I have a sharp turn like this, I'm not going to have a derivative, which means I'm not differentiable at that point. Okay? So far, we were saying we're not differentiable because we're not continuous, and we're not differentiable because the limit of the derivative doesn't exist. All right, let's move on to the next one. And then I'll throw one more graph at you before we move on. All right, what do you guys think about 87?
From 1 to infinity.
From 1 to infinity, you're saying it's differentiable. Do you want to include one or not include one?
Not include one.
Why do you not want to include one?
Because it doesn't go past 1, you don't have a limit from the left.
There you go. So,
Oh.
first thing is, am I continuous?
Yes.
Yes. And if I'm continuous, the next thing I have to ask myself is,
That's the limit.
do the limits of the derivatives exist? And in this case, the limit from the right of the derivative does exist, but the limit from the left doesn't. So since I don't have a limit from both sides, that means the derivative can't exist at that point. So that means I'm doing parentheses from 1 to infinity, and that's where I'll be differentiable. You okay with that? Okay, there's one more place. And look at, turn to page 102.
Got it.
And we're going to look at the figure on the bottom left of 102. That's our, what does that be? Our fourth situation where I'm not differentiable. And what does it say it's not differentiable? Why? It has a vertical tangent line at x equals 0. So the other reason by looking at a graph and determining something is not differentiable is if it has a vertical tangent line. Okay? But let's go ahead and talk about that function. Okay, I've got f of x equals x to the 1/3. Okay, what's the first requirement if I'm going to talk about something being differentiable? Is it continuous? So is it continuous? Yes, it is continuous. So once I determine it's continuous, what's the second thing I need to do?
Do the limit.
This limit. This limit.
The limit of the derivative exists. Okay, so what do I need to do?
Find the derivative.
Find the derivative. Okay, and where should we find out? Just by looking at the graph, where's my limit of the derivative not going to exist? It should be at 0. So let's double check that. So if I take the derivative, that's 1/3 x to the negative 2/3, so we're looking at 1 over 3 cube root of x squared. Okay, so we see the issue is going to be 0, so we want the limit as x approaches 0 from the left of my derivative, and the limit as x approaches 0 from the right of my derivative. Okay? There's no more wrong final limit. Plug in. What happens when I plug in? What happens when I plug in? I get 0 where? What do I get at the top? So what does that mean I'm dealing with? I'm dealing with an asymptote, so my two options are infinity or negative infinity. So if I'm plugging in from the left, what do I get? I get a positive. If I'm plugging in from the right, what do I get? Positive. Now, I do get the same number in this case, but what's the problem? Is infinity an actual number? Infinity is a concept. So even though they're both going to positive infinity, I'm not going to an actual y value. So since I'm not going to an actual y value, that means the limit doesn't exist. And that's why I'm not differentiable at 0. Okay? So there are four ways we've looked at on a graph to determine whether or not something is differentiable. What are my 4 ways? Sharp turn, vertical tangent line, not continuous, and
Limit of the derivative. Limit of the derivative does not exist.
I don't have both sides. A limit from, I only have a one side limit, like on number 87. Like number 87. All right, now let's do this without a graph.
Oh.
I have f of x equals the absolute value of x minus 1. So I want to talk about the differentiability of the absolute value of x minus 1. All right. It has a sharp turn in it, so I'm telling there should be a place where I am not differentiable. So let's figure that out. But before I can talk about differentiability, what's the first thing I have to talk about? Continuous. So I first need to figure out if this thing is continuous. What 3 things have to happen again? Limit has to exist. Function value has to exist. They have to equal each other. Now, since I'm dealing with an absolute value, what do I have to do to get started? Piecewise. Now, we have got to get to where we are not scared of piecewise, and we can handle piecewise. They are not hard. Pay attention to what we do. Pay attention to what we do here. There's nothing hard about what I'm getting ready to do. All right, write what's inside on the first one, and on the second one, I change the signs. Okay, now most of you guys feel pretty comfortable with that, about that.
Yeah.
It's the domain part on the right that you struggle
I
with.
think it's less than on top and then greater.
But it's still easy. It's still easy. We're going to take what's inside, make it greater than or equal to 0. We're going to take what's inside and make it less than 0. All you do is take the inside greater than or equal to 0. Take the inside less than 0.
I have to get those.
Okay, and then I can kind of simplify that a little bit. So I have x minus 1. That ends up being x is greater than 1. I have negative x plus 1, and that is x is less than 1. Now that I have my piecewise, I can figure out whether or not it's continuous. So what's the step? First step on figuring out whether or not it's continuous? Limit from the left. All right. What's my limit from the left?
Plus than.
It's the bottom one. What am I plugging in? 1. What do I get when I plug in 1? 0. So the limit from the left is 0. Where do I plug in for the limit from the right? The top. What happens when I plug in 1 from the top? So the limit from the left is 0. The limit from the right is 0, which means my limit is 0. What's the other thing I have to check? I need the function value. What am I plugging into on the function value? Top or bottom? Top. Why top? Got the equal to. So what happens when I plug it into the top? So my limit's 0, my function value is 0, those equal each other, so that means what? This function is always continuous, which means I can move on to step 2. What's step 2? Find the derivative. Now, we've never done this before, but we can find the derivatives of piecewise. Nothing fancy to it. All I have to do is take the derivative of each piece. So what's the derivative of x minus 1? 1. What's the derivative of negative x plus 1? Negative 1. Now, here's what you do on the domain. The domain stays the same, you just drop the equal sign. So it's going to be x greater than 1, x less than 1. So there's my derivative. Once I have my derivative, what do I have to check?
Limit.
Limit from the left and from the right. Okay, so the top one gives me the limit from the right, which is 1, and the bottom one gives me the limit from the left, which is negative 1. So the limit from the right is 1, the bottom is negative 1, so that means
Not differentiable.
it is not differentiable because
The limit of the
At
derivative
x
is
equals
the limit of the derivative does not exist at x equals 1. So I would not be differentiable. Okay, and you said we wouldn't be differentiable because you know the graph of this thing looks like a V. And we know there is a sharp turn, and that sharp turn tells me I should not be differentiable at that point.